Welcome to the chapter on Physics Basics. Understanding the fundamentals of physics is crucial for the chemical engineering students. In this chapter, we will cover thermodynamics, fluid mechanics, and the basics of heat transfer. Thermodynamics is the study of energy, heat, work, and how they interact. It is fundamental to understanding chemical processes. Key concepts in thermodynamics include the system and surroundings, state functions, and the first law of thermodynamics. A system is the part of the universe we are focusing on, while the surroundings are everything else. State functions are properties that depend only on the state of the system, not on how it got there, such as pressure, volume, and temperature. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed. The first law of thermodynamics can be expressed as delta U equals Q minus W, where delta U is the change in internal energy of the system, Q is the heat added to the system, and W is the work done by the system. When you heat water on a stove, you are adding heat, denoted as Q, to the system, which is the water. If the water is in a closed container, no work is done, so W equals 0. Therefore, the increase in internal energy, delta U, is equal to the heat added. Fluid mechanics is the study of fluids, which include liquids and gases, and the forces on them. It is essential for designing equipment like pumps, pipes, and reactors. Key concepts in fluid mechanics include density, denoted by ρ, which is the mass per unit volume of the fluid, pressure, represented as P, which measures the force exerted by a fluid per unit area, and flow rate, Q, which is the volume of fluid passing through a section per unit time. Bernoulli's equation shows the relationship between pressure, velocity, and height in a moving fluid. The formula is P plus 1/2 rho v squared plus rho g h equals constant. In this equation, P stands for the pressure, rho is the fluid's density, v is the velocity, and h is the height above a reference point. As the velocity of the fluid increases, the pressure decreases, and the reverse is also true. Consider water flowing through a pipe that narrows. According to Bernoulli's principle, as the pipe narrows, the velocity of the water increases and the pressure decreases. Heat transfer is the movement of thermal energy from one object or substance to another. It is crucial in processes like heating, cooling, and chemical reactions. Key concepts in heat transfer include conduction, which is heat transfer through a solid material, convection, which is heat transfer through a fluid due to fluid motion, and radiation, which is heat transfer through electromagnetic waves. Fourier's law of conduction is given by the formula Q equals negative K times the gradient of T. In this equation, Q represents the heat flux, which is the amount of heat transferred per unit area per unit time. The term K is the thermal conductivity of the material, indicating how well it conducts heat. The symbol nabla T refers to the temperature gradient across the material. Heat always flows from hotter regions to cooler ones. When insulating a house, materials with low thermal conductivity, denoted as K, are used to reduce heat loss through conduction. This helps keep the house warm in winter and cool in summer. Understanding the basics of thermodynamics, fluid mechanics, and heat transfer is essential for chemical engineering students. These principles form the foundation for analyzing and designing chemical processes and equipment.